For weeks, astronomers around the world waited in suspense. Not because they lacked theories about interstellar object 3I, Atlas, but because they lacked something far more valuable: visibility. Earth-based observatories had entered a blind window. Solar glare overwhelmed instruments. Dust interference complicated measurements. Telescopes that had tracked the object were effectively staring into light. And while much of the scientific community could do little but model possibilities, one spacecraft kept watching. High above Mars, in quiet orbit, TNIN-1 occupied a vantage point no Earth observatory could match. And now, with newly released imagery and instrument data, that silence has broken. What TNIN-1 reportedly captured does not suggest alien contact or impossible physics. But it does reveal something genuinely compelling: an interstellar visitor behaving in ways that may stretch and refine our models of cometary behavior. And that is mystery enough. The story begins with geometry. At the exact moment Earth lost sight of 3I, ATLAS due to solar proximity, TNIN-1's position around Mars provided a clear line of sight through interplanetary space. No atmosphere. No horizon interference. No solar washout. For a brief but critical window, Mars became the best observatory in the solar system. And during that window, TNIN-1 kept watching. That matters because near perihelion, comets reveal their true nature. Activity intensifies. Sublimation increases. Jets form. Dust evolves rapidly. Fragmentation risks grow. Scientists expected chaos. Instead, the images suggest something remarkably coherent. The comet thickened rather than dispersed. Jet activity appeared organized. Dust production remained steady. Brightness increased, but without signs of catastrophic breakup. That alone raised questions. Because under intense solar heating, instability is expected. Yet this object appeared resilient. Then came another layer of complexity. Measurements showed periodic fluctuations in brightness, not random flickering, but rhythmic variation. Possibly rotation. Possibly repeating activity cycles. Such variations are not unheard of. But the regularity and strength hinted at something unusually active. Perhaps rapid rotation. Perhaps layered outgassing. Perhaps geometry we do not yet fully understand. Whatever the cause, the data suggested complexity, and TNIN-1 captured it while Earth could not. As the object moved closer to the Sun, another surprise emerged. Jet structures appeared more directional than expected. Not chaotic sprays, but organized streams shaping the tail in striking ways. Even more intriguing was the development of an anti-tail, a visual effect where dust appears to point toward the Sun due to orbital geometry. Anti-tails are known phenomena. But this one seemed to evolve faster and more dramatically than expected. Then came the paradox. Brightness increased significantly, yet fragmentation remained absent. Normally, higher activity suggests breakup or instability. But here, the nucleus appeared intact. That points to unusual composition, perhaps a porous structure, layered volatile reservoirs, or internal cavities. Something about it does not fit standard assumptions. And the mystery deepened further. Researchers noted subtle structures within the coma, asymmetries, dark regions, repeating patterns across images. Not artificial. Not engineered. But persistent enough to demand attention. Then came one of the most debated observations: a brightening on the side facing away from the Sun. That challenges intuition. Solar heating should dominate the sunward side. So what explains activity elsewhere? There are possibilities. Thermal lag. complex rotation, dust scattering, shadow-driven sublimation. None require new physics. But none are simple either. And simplicity was fading. What makes this remarkable is not that TNIN-1 discovered something unnatural, but that it revealed nature to be more intricate than expected. And sometimes, that is even more profound. Because reality does not need science fiction to be astonishing. As scientists examined the data, another realization emerged. Earth had missed part of the story. For generations, discovery has been Earth-centered. But during this event, another world had the better view. A spacecraft orbiting Mars became humanity's observer. And that shift matters. Because it hints at a future where discovery is not confined to Earth, but shared across the solar system. Mars orbiters, lunar observatories, deep space probes, multiple worlds watching together. Still, key questions remain. How does this object sustain such activity without breaking apart? Why are its jets so coherent? What drives its unusual brightness behavior? Each question points not to broken physics, but to incomplete understanding. And that is where discovery begins. There is something almost poetic here. An object older than our solar system, formed around another star, now passing through our cosmic neighborhood.